Hello students, once again welcome to Bholanath Academy. In this video students we are going to see the lesson 10, that is magnetic fields due to electric current. Magnetic field due to electric current. In that students we have question in a board examination. They are asking what are Biot-Savart Law. State the Biot-Savart Law, that is also called as Laplace Law, for the magnetic induction produced by a current element. Okay students, in board examination they may ask for 2 marks question. So you have to start like this students. Consider a conductor carrying current I, small I. Imagine conductor is divided into the large number of very small elements. Students, you have to consider a element QR of length is given, that is DL, carrying current I. Okay students, so you have to imagine a conductor that is divided into large number of very. Consider an element QR of length DL carrying current I. Here students I have shown. So current I is going in the wire is there. Okay students, we have divided this imaginary wire into small elements. This is QR students. Small element I have taken, that is QR. Now you have to find the magnetic induction, small magnetic induction. That is why we have taken a small dB. B stands for magnetic induction produced at point P. Let P be the point at a distance r from this center of the element. Okay students, this element QR we have taken. Length of QR is given DL, small element we have taken, so the distance will be also small DL. Let P be the point at a distance r from a center of element, and theta be the angle between them. Okay students, so here students, a small element, that is DL bar, and distance we have shown with R bar. According to Biot-Savart Law, a small magnetic induction, that is small dB, we call a small magnetic induction at point P. Here the point is given due to the current I through the element is as follows students. So students, when the current will pass from this wire students, so here it will produce a small magnetic induction we have shown with a small dB, that is directly proportional to the amount of current which is passed inside the wire. So dB, you can say it is directly proportional to I also. Okay students, as the current increases, magnetic induction also increases. That is why we have taken it is directly proportional. dB is directly proportional to I. Now what happens students? Magnetic induction, small magnetic induction, is also directly proportional to the length. As the length of this element increases, magnetic induction. That is why here I have already shown it is also directly proportional to DL. Now magnetic induction is also increases because of the change in sin theta. So it is also directly proportional to sin theta. Okay students, magnetic induction which is inversely proportional to the distance between this element and the point P. As the R increases, magnetic induction decreases. That is why we have shown it is inversely proportional. It is inversely proportional to the distance, that is dB is equals to 1 upon R square. Okay students, now all these 4 proportionality we have written in one way students. This we have written in only one, that is dB is directly dB is proportional to, now we will see it is proportional to I dl sin theta. You have to multiply all this, it is in numerator I dl sin theta, and this R square will be at denominator, that is R square. Okay students, now you have to remove the proportionality constant. For that students I have put K. So dB now is equal to the K I dl sin theta upon R square. Okay students, dB is now it is equals to K I dl sin theta upon R square. So this is the small magnetic induction produced at point P. Understand, very important students. So this is the very important formula. With the help of this formula students, now we are going to solve so many problems. In SI system students, SI K is nothing but mu 0 upon 4 pi. Okay students, these are the constant values, mu 0 upon 4 pi. So small magnetic induction at point P is equals to mu 0 upon 4 pi into I dl sin theta upon R. This is scalar quantity students. Now in vector form students, you can represent like this. dB bar is equals to mu 0 upon 4 pi, which is scalar quantity, is equals to I dl bar cross. Now since it is vector product students, you have to put the cross R cap. This is R cap students upon R square, where R cap is nothing but R bar divided by R. So this is very important students. In this way students, you have to represent the answer in board examination. It is very important. If you like my video, please share it, subscribe it. Thank you very much. Have a nice day. God bless you.